The spectroscopic observations from Gemini South and the NASA Infrared Telescope facility have revealed strong water ice signatures mixed with carbonaceous minerals and silicates. The water ice shows characteristics suggesting it could be chemically pristine, lacking the heavy isotopic signatures we typically see in solar system comets. This water could have formed billions of years ago in a completely different stellar environment, giving us a direct window into how planetary systems form elsewhere in the galaxy. But even this cometary evidence doesn't settle the debate. In fact, it might support the artificial hypothesis in an unexpected way. If 3I Atlas is indeed some kind of probe or spacecraft, the dust and ice we're observing could simply be accumulated material from its long journey through interstellar space. Cosmic debris that's built up on its surface over millions or billions of years of travel. Now let's talk about that trajectory, because this is where the evidence for something unusual really starts to pile up. In their paper, Is the Interstellar Object 3I Atlas Alien Technology? Loeb and his collaborators present statistical analysis that's genuinely unsettling. 3I Atlas is traveling on a retrograde orbit that's tilted only about 5 degrees from the ecliptic plane, where Earth and most planets orbit. The probability of this happening by random chance? They calculated at roughly 0.2%. But it gets more intriguing when you look at the planetary encounters. This object is going to make remarkably close approaches to multiple planets. It'll pass within about 29 million kilometers of Mars on October 3rd, reach perihelion at 1.35 astronomical units on October 29th, and later swing within 33 million kilometers of Jupiter. The combined probability of a random interstellar object making such close approaches to 3 major planets? Approximately 0.005%. That's 1 in 20,000 odds. Here's another detail that's raising eyebrows. I-Atlas reaches its closest approach to the Sun when Earth is on the opposite side of our star. We literally won't be able to observe it during this critical phase. If you were designing a spacecraft to conduct operations while avoiding scrutiny from Earth-based telescopes, this timing would be absolutely perfect. Loeb calls this a potential reverse solar Oberth maneuver, a high-thrust braking strategy that could allow an interstellar craft to slow down and potentially remain in our solar system. The fact that this maneuver would be completely hidden from Earth's view by solar glare is either an incredible coincidence or evidence of deliberate planning. But let's be clear about the scientific consensus. The majority of astronomers studying 3I Atlas believe it's a natural interstellar comet, and they have good reasons for this position. David Jewett from UCLA, who's been analyzing the Hubble data, points out that 3I Atlas is displaying classic signatures of cometary behavior. The dust production rate they've measured, between 6 and 60 kilograms per second, falls within expected ranges for comet activity. The ejection velocities of 20 to 2,000 meters per second also match what we see in normal comets. Moreover, the fact that we haven't yet detected volatile gases like cyanogen or diatomic carbon isn't unusual. 3I Atlas is still about 4 astronomical units from the Sun, roughly Jupiter's distance. Most comets don't start showing strong gas emissions until they get much closer, and solar heating really intensifies. The self-illumination hypothesis also faces challenges. If 3I Atlas were generating its own light through some kind of nuclear process, it would need to produce roughly 10 gigawatts of power. That's equivalent to several large power plants. Maintaining that kind of energy output over the millions of years of interstellar travel would require either an enormous fuel supply or technology far beyond our current understanding. The next few months represent a critical observation window. As 3I Atlas approaches the Sun, we should start seeing those telltale gas emissions if it's truly a comet. The James Webb Space Telescope has this object in its sights, and its infrared capabilities could reveal unprecedented details about its temperature profile and energy output. There's also an exciting possibility involving Mars-based observations. When 3I Atlas passes close to Mars in early October, there's talk of using the HiRISE camera on the Mars Reconnaissance Orbiter to capture high-resolution images. This could give us our best close-up look at an interstellar object's surface, and potentially resolve the question of whether we're seeing reflected sunlight or self-generated illumination. But here's what really has me excited about the future. The Vera C. Rubin Observatory has just begun operations. This revolutionary facility will detect dozens of interstellar objects annually, giving us the statistical sample we need to understand what's normal and what's truly anomalous.